So the next experiment is we are going to talk about flip-flop. I strongly believe that everyone knows flip-flop. Flip-flop can store how many data? Yeah, flip-flop basically can store 1 bit data. It can have a state of 1, otherwise it can be in the state of 0. We have various classification of flip-flop starting from SR flip-flop. Then we can talk about JK flip-flop, D flip-flop and T flip-flop. And in our lab exercise we have flip-flop like JK, D and T flip-flop. So before proceeding to JK flip-flop, let us see what is SR flip-flop is all about. What do you mean by SR flip-flop, guys? Any idea what S stands for?
Set.
Yeah. S stands for set, R stands for reset. So basically SR flip-flop is set, reset, flip-flop. Right. So this is the logic diagram of the SR flip-flop. We have two input. One is S, which is set, and second one is R, which is reset. And then the output state is Q, and the other one is Q bar. So always Q and Q bar cannot be same. If Q is equal to 1, Q bar should be equivalent to 0, and if Q is equal to 0, Q bar should be equivalent to 1. This condition should be satisfied for all the flip-flop. When this condition is not satisfied, then it is violating the basic condition of being a flip-flop. So having said that, let us move on to the truth table of the SR flip-flop. So the first case, when I am going to give the input as 0 and 0, the output is going to remain as the previous state. If the previous state is going to be 1, the next state also is going to be 1. If the previous state is going to be 0, the next state will also be 0. Second case, 0, 1. 1 stands for, what is this corresponds to? It corresponds to reset. So the output should be, irrespective of whatever may be the previous state, the next state should be equivalent to 0. And next, what is this 1 corresponds to? It corresponds to set. So irrespective of whatever may be the previous state, now the next state should be set as 1. And the last option, 1 and 1. When you give 1 and 1, in SR flip-flop, we will not able to predict what is the output. So which basically tells that it is not matching the fundamental rules of a flip-flop. As I said, either it can be 1 or 0, but if you are unable to predict what is the state, then it is violating the fundamental nature of this particular flip-flop. Even though our experiment we are going to talk about JK flip-flop, I just given a brief introduction about SR flip-flop because we have a certain disadvantage. What is the disadvantage? When both the inputs are 1 and 1, the output is indeterminate. To overcome this particular disadvantage, we are going for JK flip-flop. So as I said, we have a disadvantage in SR flip-flop, that is when you give both the input as 1 and 1, the output will not able to determine what is the output. To overcome that particular disadvantage, now we are moving to a flip-flop called as JK flip-flop. The main advantage of the JK flip-flop is when you give the input as 1 and 1, instead of output which you are unable to determine in the previous case, that is for SR flip-flop, here the output will toggle. What do you mean by toggle? When the previous state is going to be 1, if I give the input as 1 and 1, the output will become from 1 will go to 0. And similarly, if the previous state is going to be 0, when I give the input as 1 and 1, the output will go to 1. So it will keep on toggling. Okay. For remaining all the three cases, it will act very much similar to that of the SR flip-flop. Let us quickly look into the, this is the diagram of JK flip-flop. We have got two input J and K, and then we have the output Q and we have a Q bar. So as you all know that Q and Q bar always should be complement of each other. So let us quickly look into the truth table of the same. So this is the, we can also design the JK flip-flop using the NAND gate, and this particular diagram indicates the same. Let us look into the truth table. So first case, which will be quite similar to that of the SR flip-flop. When J is equal to 0 and K is equal to 0, what will be the output? The output will remain in the same state. If the previous state is going to be 1, output will be still 1, and if the previous state is going to be 0, output will still remain 0. Second case, 0 and 1. What does this indicate? What is this equivalent? It is equivalent to reset of the SR flip-flop. So whenever the value of K is equal to 1, whatever may be the previous state, the next state will be equivalent to 0, which indicates reset. And then whenever you are going to give 1 0, what will happen? This is equivalent of set operation in SR flip-flop. So irrespective of whatever may be the input, when we give 1 0 as an input, the output is going to be 1. The problem that we had in SR flip-flop, when we give 1 and 1 as an input, what will be the output? The output will be indeterminate. That is the issue we had with SR flip-flop. Now in this case, when we give 1 and 1 as an input, output will toggle. If the input is 1, if the previous state was 1, the next state is going to be 0. Otherwise, if the previous state is 0, the next state is going to be 1. Yes? So now let us quickly look into the order implementation of this.
Okay, sir.
Yes. So the IC that we are going to use for implementing the JK flip-flop is IC 7476. Okay, this is the block diagram just we have seen. This is the pin configuration of the IC 7476. Probably you can look into it. Now let us see how it is going to work with the help of the logic gate. You could able to see this is the connection for the IC 7476, and these two are the input. One is J, other one is K, and these are the output. One is Q, other one is the Q bar. And then here you could able to see, okay, I have given the clock pulse manually because each and every time when I press the clock pulse, I could able to see the change of the state over here. So now initially the input of J and K are 0 0. You could able to see even if I am going to give the clock pulse, there is no change in the output state. Second case, J is equal to 0 and K is equal to 1. Basically it should happen reset. That means here 0 should come, here 1 should come. Now let us apply the clock pulse and see what is the change which is happening. I am applying clock pulse as expected. We could able to see it is reset operation. And now when J is 1 and K is equal to 0, basically it is going to set. That means this is going to be 1 and this is going to be 0. Let me press the clock pulse so that I can able to see the change in the state. I am pressing the clock pulse and as expected J is equal to 1, and when J is equal to 1 and K is equal to 0, the operation is set operation is taking place. And the last operation, when both are 1, when I give the clock pulse, the output state should toggle. So I am giving the clock pulse, you could able to see the state is getting changed. So this is the operation of JK flip-flop.